this is diagonal AC. We can draw it separately as this, and this is the point M1. Similarly, this is the diagonal DB, and the point M2 is the midpoint of DB. Here we go. So in order to prove our result, we are going to show that M1 and M2 points are equal. To show that, we are going to show AM1 and AM2 vectors are equal. First we find out AM2 vector. We can write it as a sum of two another vectors, M2. We can write it as AB plus BM2. Here, what is BM2 vector? The point B is here, point M2 is here. Also, M2 is the midpoint of BD. So, we can write BM2 as half times vector BD. Also, we can notice vector AB as sum of half times vector AB plus half times vector AB. Now we are going to use these two data in this equation. Half times vector AB plus half times vector AB plus half times vector BD. Take a look at these two sides, namely AB and DC sides. What can we find out about them? The magnitudes are equal because these sides are on a parallelogram. They are also parallel, so they have same magnitude and same direction. Therefore, these two sides are vectors. So we can write vector AB equals vector DC. We can use this data in this half times vector AB plus half times we use this data vector DC plus half times vector BD. After that, we can rearrange this addition. We can get AB plus half times BD plus half times DC. Now we have half as a scalar coefficient in three vectors, so we can take it out as a like this. Now we have vector AB plus vector BD plus vector DC. Here we can notice these two vectors are equal to vector AD using the triangular law of addition in vectors. Now we have DC here. Similarly, in this situation we can write vector AC. Finally we have a result similar and simpler result. Vector AM2 is equal to half times AC. Let's now consider about AM1 vector. We can write M1 as the midpoint of diagonal AC here. So AM1 vector, we can clearly see that it is half the time of magnitude AC. Also, we can clearly identify the vector AC is parallel to vector AM1. So we can write AM1 vector as half times vector AC. Let's take this as equation number 2. We got equation using AM2 as number 1. What can you say now? Yes, 1 equal to, that means AM1 vector is equal to AM2.